Hello guys, in this video we are going to be looking at laws of logarithms. So LOLs, if you will. Laws of logarithms. Here's a blank copy and here's the key. Okay, so let's go ahead and go to the notes. And we're going to start off first by looking at what are the values to these specific equations from what we already know and understand of logarithms, and then we'll develop our laws. Okay, so log base 2 of 8. We know log base 2 of 8 from what we know so far to look like this. And if we set it equal to something, we know the reverse Hart method starts at the base, and we could create an exponential function of 2 to the power of something is equal to 8. Well, that something would be 3. So that means if this something is 3, then this right here was 3. Okay, so let's go ahead and write just 3 right here. And then log base 2 of 4. Again, the best way to find, by hand especially, the best way to find the value of a logarithmic function is to rewrite it as an exponential. So 2 to the power of question mark, if you will equal 4. Well, question mark would have to equal 2. Therefore, all of this value is going to be 2. Okay, so really what this is saying is 3 plus 2. So 3 plus 2 is equal, obviously, to 5. Okay, so log base 2 of something is equal to 5. Okay, if I did this other one, log base 3 of 9, just real quick, log base 3 of 9. I'm only going to do this for the first couple, and then we'll go ahead and go with the notes. Log base 3 of 9 is equal to something. So 3 to the power of something is 9. That something has to be 2. Okay, and then log base 3 of 81. Again, rewriting an exponential form would have reverse Hart method, just like we did here and all the other ones. Would be 3 to the power of question mark is 81, so that would be 4. So 2 plus 4 is equal to 6. So this is really saying log base 3 of something equals 6. Okay, over here for the log base 3 of 1/9, I'm only going to show this last one because I want to make sure that you're understanding how to do negative powers. Okay, so let's do this last one over here. Let me make some room. And then we will write it as log base 3 of 1/9 is equal to question mark. Therefore, reverse Hart method says 3 to the power of something is 1/9. And when we have fractions like this, a good way to figure out what that question mark would be is to try to get the same bases. Right now I have a base of this 3 and kind of a base of 1/9. But I know 9 and 3 share factors. And this is something very, very important that we need to learn from this unit, is that 9 can be written as 1 over 3 squared. Okay? And again, I want them to have the same base. It's like I want to have it base raised to a power is equal to a base raised to a power. They almost look the same, okay? So to bring this 3 squared upstairs, I'm going to undo what we've learned before of making negative exponents into positive. So I'm going to bring this up and make it into a negative on the right side, and then I still have my 3 squared on the left. And just like in videos past, if I have the same base, that becomes negligible. And now it's all about what is that power equivalent to, okay? So right here, what I'm looking at is I'm going to rewrite this 1/9 to be something. Let me show you what I'm talking about. It's going to be 3 to the negative 2, okay? So this 1/9, and I just realized what I did. This question mark should have been a question mark here and a question mark there. So question mark is now equal to a negative 2. Okay, so if you need to rewind that video just real quick, that's fine. My bad on that, but that was a question mark. So now question mark is equal to negative 2. Okay, so question mark equals negative 2 means this was negative 2, means all of this over here originally should have been represented with a negative 2. And then log base 3 of 81, we knew from up here was 4, so that we get 2. So this is going to be 2. And then now real quick for the sake of time, log base 5 of 5 is 1, and log base 5 of 1 is 0. So this would be equal to 1. Okay, so this would also equal to 1. So we're trying to find out the log base 2 of something over here would equal 5. That's like 2 raised to the 5th power is x. Well, 2 raised to the 5th power is 32. So the 32 belongs in there. Okay? And you might have to rewind this video just a little bit to see what are the patterns that we're actually looking at, because there's a lot of numbers just going on right now. But let's do a couple more. 3 to the power of 6 is equal to something. And 3 to the power of 6 is going to equal 729. Okay? So 729 would go here. And then 3 squared is 9. So 9 goes in here. And then 5 raised to the 1 power is just 5. So 5 would go right here. Okay? So what we just did from the knowledge of logs that we know is that we just learned that this 8 and 4 came together as an 82, as a 32. This 9 and 81 came together as a 729. 1/9 and 81 became a 9, and a 5 and a 1 became a 5. So what's happening here? Well, the big thing that you should have realized and learned from this is that when I'm adding logs that have the same base, they must have the same base. If they don't, you cannot do what I'm about to show you. So when they have the same base and I'm adding logs together, what we end up doing is we take this first argument and we multiply with the second argument. So it'd be x times y. Okay? So whenever you are adding, you end up multiplying. Notice that I had 2 logs here that combine together into 1. Okay? They combine together into 1. And when I combined them, the addition became a multiplication in between those 2 pieces in the same argument. Okay, so let's get a lot of practice with this. Okay, so we're going to use the new rule to solve problems that were impossible before. Okay, so now, looking at this, if I rewrote this, okay, so it's all about the rewrite, this is going to be log base 6 of something. And the reason why I can bring these two together, because this is addition, I will end up getting this 12 times 3, which is the same as just 36. So log base 6 of 36 is what this ultimately became. So this right here was a product of this 12 times 3. Okay, again, why did we multiply? Because it's adding. These are adding. So we're going to see what happens if it's subtraction here in just a bit. So adding, we multiply. Okay, and then yes, the following we're still going to multiply. So we'll have 1 log. Notice that the log is base 10 because nothing is written there. It's a common base of 10. We don't have to write it here either. We've got to remember that it's going to be 250 times 40. Okay, so let's go ahead and do this off to the side. 25 times 4, we know is 100. And then we have these other zeros here, so we need to tack on 2 more hundreds. So this is the same as log of 10,000. Okay, and then keep going. The next one, we're still going to multiply. We're going to multiply and combine these into 1 log base 8 with a 1 argument. And it's going to be 3/64 multiplied with 1/3. Okay, notice that these are going to cancel, reduce to a form of 1, and all we have left is 1/64. So our answer would become log base 8 of 1/64. All right, so let's go ahead and move on. Our next one is going to be subtraction. Okay, and the subtraction, you probably guessed it, is not going to be multiplying. We're actually going to be dividing. So again, the same rules apply. I must have the same base. And then when I look at between 2 separate logarithms, okay, these are 2, they're going to combine again to 1. So these combine to 1 logarithm, and because it's x minus y, then it is very order specific. It has to be x divided by y. You cannot have y divided by x, not in this case. The way that you would need that to be written would be the y would have to be first, and then you would have the x. That's the only way that you're going to be able to say that it's y divided by x. So order matters, because order matters with subtraction, okay? Order matters with division, okay? So like 3 divided by 1, that's 3, but 1 divided by 3, that's 1/3. Order matters. 3 minus 1 is 2, but 1 minus 3 is a -2. Again, order matters. Back here, it didn't matter because addition and multiplication, order doesn't matter, okay? But over here, you have to be careful as far as that goes, okay? So let's see real quick where this came from. If I were to solve these out independently, log base 5 of 625, again, I can do it the way that I did it on the other slide just moments ago, or I could even punch it in my calculator and I'll get a 4, okay? Now, we are not going to punch it in the calculator because that kind of defeats the purpose of what we're discovering with these subtractions. But log base 5 of 5 is 1. And if I'm subtracting, I'm going to get 3. Okay? And that 3 would end up becoming this value here. And then you would ask yourself, 5 to the third power equals something. Well, it's 125. And again, you guessed it. I'm subtracting things with the same base. So what am I going to do to their arguments? I'm going to divide them. So 625 divided by 5 ends up becoming 125. Okay. Log base 6 of 6 is going to be 2. Okay. And then we're going to subtract 1. This gives me 1. And then we would ask ourselves from here, reverse heart method, 6 to the power of 1 is 6. Okay, so this value right here that we got is what we're going to go here with, writing down 6. And yes, you guessed it, because these bases were the same and it was subtraction, it would be 36 divided by 6 would give me this 6 that I got over here. Okay, so that's what's going on. I'll go ahead and fill it out because I don't want to make this video long. 2 minus 0 would give us 2. 3 to the power of 2 would give us 9. Then we have log base 2 of 16 would be 4 minus log base 2 of 32, which would be 5. We get -1. And then this one is just a little bit tricky. It'd be 2 to the power of -1 is equal to something. Well, this is the same as 1 over 2 to the power of +1. Remember, there's an understood 1 that exists when I move this into a denominator. Okay, so then we just get 1/2. All right, so now let's go ahead and do some practice with these. We're going to combine these two into one because they have the same log. Again, if they don't have the same log, I cannot do this. Okay, so log base 6 of, it is going to be order specific, 72 divided by 2. So this would just become 36. Okay, so I have log base 6 of 36. And if I simplify it all the way out, let's say I don't know what this equals. If I simplified it all the way out, I can, of course, do the reverse heart method. Our goal is to be able to do this without a calculator for sure. For all the various tests that you have, non-calculator portions of AP exams, non-calculator portions of SATs, so on and so forth. That's the goal, is to get this to also be non-calculator. So question mark would equal 2. So my final answer would just be 2. All of this becomes 2, okay? Okay, I want to just make sure that we did, in fact, simplify this other one as well. So let me go back. And this one's going to become 2 because 6 raised to the power of something will give you 36. Again, you're doing that by hand. Let me show the intermittent work just a bit because it is important. That's why I'm going back to it. This is equal to something, okay? We'll just say question mark, question mark, question mark. So it's going to be 6 to the power of something is 36. Well, that something has to be 2. Then I have an understood common base of 10. 10 to the power of something is 10,000. Well, that's going to be 4, okay? Because I have 4 zeros here that this 10 will end up becoming. And then 8 to the power of something is going to be 1/64. Okay, so we could say 8 to the power of something is 1/64. I've done this with other problems similar in nature as far as trying to get the same base. So this could be written as 2 to the power of 3, written raised to the power of this question mark. All I did was replace 8 with 2 to the power of 3. This down here is 64 is like 2 to the power of 6, okay? And it's 1 over 2 to the power of 6. So yes, I will bring this up to match. So now I have the same base of 2. I just have to do power raised to a power and say that 3 times question mark would give me 3 question mark. Otherwise, 3x, I mean, it's the same, is equal to 2 to the negative 6. And now that they're the same base, again, I've done this before, I'm doing it for extra practice, the powers set equal to each other is what you're going to solve for. So you'd get negative 2. So x is negative 2. Otherwise, question mark is negative 2. So if this is negative 2, that means this whole thing came out to a negative 2. Okay? Again, you've asked as a collective whole to make the videos a little bit more brief. So if you do need to rewind, pause, or whatever, please feel free to do so. Okay, so now let's go back to our dividing. Okay, we do have a common base of 10. Therefore, we would divide 12 divided by 0.12, if you will. And we would get this log base 10 of this, and we'll see whatever it equaled. Because remember, this simplified all the way to 2. We want to see what this simplifies to. Okay? And yes, we don't usually, please do not do this. Don't write decimals inside of a fraction. You want to either have it all fraction reduced or all decimal reduced. Okay? So let's see how we can work this as far as by hand of simplifying these values. Okay? So let's go ahead and change 0.12 into an actual, and this again is with the premise that we're doing this by hand. 0.12 is the same as 12 100ths. So if I have, let me write it out, this 12 is divided by 12 100ths. Now this looks really weird, but if I wrote it like 12 divided by 12 100ths, there's a strategy here. You learned in 5th grade, keep, change, flip when you're dividing by fractions. So 12 divided by 12 hundredths is the same as multiply by the reciprocal. And notice that this 12 here is an over and understood 1, which will easily be identifiable of canceling with that 12. So what we're really looking at is log of 100. So this will change to log of 100. And yes, if I wanted to simplify it even further from all the knowledge that I've been building and kind of putting together, this is equal to something. And 10 to the power of something, to get me 100, that something would have to be 2. So all of this, what does it simplify to? It all simplifies just to a 2. So we could say is equal to 2. Now again, this is the answer of all of that. And without a calculator, that's what I'm going to go to. And one more reminder, since nothing was written here and here, the common base is 10. Okay, so there is a lot that you remember. This is what makes exponential and logarithm functions difficult, I believe, for students, because there is a lot of things to remember. There are a lot of small little details, and you're kind of combining and putting them all together. And you got to know when and where and how to use all that. And notice we're still using mostly numbers right now. When we start using equations and stuff, it does get involved. So please, please memorize these laws of logs as quickly as possible. Okay, so now with this rule, whenever we have the same and we're subtracting, same base is going to be 12, and now it's going to be 2 divided by 288, which I'll just go ahead and reduce to 1 over 144. Okay, now if I wanted to see what this is equal to, again, my strategy is without a calculator. I have 12 written to the power of x is 1 over 144, aka 1 over 12 squared. And the reason why I say that is I want you to already be thinking, what do they have in common? Like, what factors are these having in common where I can assign the same base to? Okay, so this would come upstairs by making it a negative 2. And I still have 12x over here. So x is going to be equal to negative 2. So all of this ended up becoming a negative 2, which was the answer to that simplified form. All right, so let us keep going. All right, so part 3 says evaluate these expressions using your understanding of logs. So we're going to start combining even more knowledge together. I kind of have already introduced some of the things in videos past, but no worries, here we go. We're going to look at 2 to the power of something is equal to 4 to the power of 3. Okay, so like I just showed you in that previous problem, I'm trying to find this base and this base to kind of have the same things in mind. And it's all about the rewrite. For sure, it's all about the rewrite. And the rewrite of many of you are probably asking, how did you know to do that? Or how did you think to do that? And it comes with practice. You have to practice, do your homework, those extra things that we have for you. If you don't feel confident, the optionals that we have in the calendar or whatnot, feel free to do those. It will help you with practice. That way, this part becomes a lot easier and it's easier to see. Okay, so this is all equal to, let's say, some kind of question mark. So let me put it over here. Log base 2 of 4 raised to the third power, we're going to say is something. Reverse Hart method tells us the easier way to look at this is 2 raised to the power question mark is 4 raised to the power of 3. Well, now look at their bases. Remember, our goal was to get some base raised to a power equal to some base raised to a power for this specific problem. Well, this 2, I know has a base of 2 because I can rewrite it as 2 squared. 2 squared is the same as 4. So I have 2 question mark is equal to this raised to the third power. And the reason why I did that is because now I want to write this as 2 raised to the power of 6. Powers raised to a power, we multiply. A lot of previous knowledge combined together with what we were learning now. So we have 2 to the power of question mark is equal to 2 to the power of 6. Therefore, this right here is 6. Because remember, all this equaled question mark. Okay? And if question mark is 6, then all of this is going to equal this 6. Okay, so now let's go to number 18. Again, we're trying to build a understanding because we all know we could just put these in the calculator. That's not what we're trying to do. It's for those non-calculator testing questions, okay? And please don't think about, oh, we're in e-learning right now. We don't have to learn this because we can use the calculator at home. No, that's not the premise. Think of your future maths and the non-calculator testing that you're going to be doing with that. Okay, so I have log base 3 of square root of 9. Well, square root of 9 we know is just 3. Okay, so if I set it equal to a question mark, then it's 3 to the power of question mark is 3, and the only way that'll happen is if it's 1. Okay, so now we have 5 to the power of 2, so 25 if you will. And you can write it 2 different ways, okay? You can write it as 5 raised to the power of question mark is 5 squared, or if you wanted to just look at 5 squared as 25, again, I'm doing like the reverse Hart method, just saving some time. I would have 5 to the question mark is equal to 25. Now, these are easier to see because you can see 5 squared would be 25. But the reason why I was showing you before with how I did this one and had the power raised to a power bit so I could simplify and see, those are for the more involved ones, okay? So these that are easier to see, yes, you don't have to break it all the way down to this if you don't want to. You just know the answer is 2. But I'm really looking at for these and other ones that are a little bit more difficult and not easy to see as far as 5 squared or stuff like that. Okay, so we're going to say that this is raised to the power of something is equal to this. Oops. So 3 raised to the power of question mark is what this has here. Again, we got this from reverse Hart method. And therefore question mark has to be 95. So these can be difficult if you're not understanding what's really going on here. But again, use the question mark or use the x. If you wanted to say all this was equal to the power of x, then 3 to the power of x is equal to 3 to the power of 95. Like we've mentioned before, when these are the same, it's negligible. Now you just look at the powers and set those equal to each other and solve for x. Well, x is going to be 95. Okay? Many ways to look at this. It all depends on your experience and practice. So there would be 95 right here. All right, so now, what pattern seems to hold? Okay, so what we're going to look at right now is what pattern is happening with what we see. Okay, And it's called it's one of the laws of logs to where I have a power here that I can now bring out in front as a coefficient that will be multiplying by all of this that's left over. Okay, so like over here, this one right here, if I were to go back and rewrite this power of 3 would go out in front and it would be multiplied with log base 2 of 4. Well, log base 2 of 4 is 2 times 3 gives you 6. Okay, this one right here was 9 raised to the 1/2 power. That means if I brought the 1/2 out in front and everything else stayed the same, log base 3 of 9, then this log base 3 of 9, well, that's just 2 times 1/2 gives you 1. Again, so this 2 would be moved and this 95 would be moved. So the 2 moves out in front. And when I'm saying that these are moving, they're the powers that are moving out in front, guys. So 2 gets rewritten with this log base 5 of 5, which we know log base 5 of 5 is just 1. And 1 times 2 gives you 2. Okay, and then this last one, the 95 got written out in front. Log base 3 of 3. Remember, the power goes away. You don't see the power anymore inside of the argument that's attached to A. It moves out in front over here. Okay, and log base 3 of 3 is 1 times 95 gives you the 95. So let's look at these examples. It says use the new rule to solve these that were a little bit impossible before. Remember, this is a base of 10, a common base of 10. Okay, so what we're going to do is we're going to rewrite this as the log base 10 of the square root of 1,000. Well, the square root of 1,000 looks like this, but this is important. I want you to know all of this is still in the argument. It's like this would be like the parentheses over here. We just rewrote it with a fractional exponent. Okay, and from this rule, we're going to take this power of C and we're going to move it out in front. So we're going to take this. Look, it's inside. This is inside of the parentheses. That is what's moving. If it was on the outside, you couldn't use this law. Okay, the 1/2 is whenever it's inside of the argument. So this is going to be equal to, that's very important, guys, 1/2 times the log base 10 of 1,000. Well, the log base 10 of 1,000 is 3, and times 1/2 is going to give you 3/2. So all of this without a calculator becomes 3/2. And you'll use this in a lot of future math for sure. Again, all non-calculator portions, mostly. As far as this one is concerned, we're going to go ahead and move this power of y that's inside of the argument as a coefficient that's on ground level multiplied with this log base n of n. Well, we know that this is just 1. When you have the base and the argument the same, it's going to be 1. It cancels out. And then you're just left with y times 1. And then over here, log base e of e. So log base e of e, there is an understood power of 1. And if we moved it out in front, then we have log base e of e. Okay? And the log base e of e, again, when the argument and the base are both the same, it's going to cancel to a form of 1. So it's 1 times this 1, which just gives you 1. Okay? Quick review, log base e is the same as natural log. So if I'm talking about this e right here, I know that this is just 1. And if I'm talking about this is also e, then I should know by now that the natural log of e is 1. They cancel each other off and they become 1. Okay? Just real quick so that you know, the natural log graph that we've discovered and kind of talked about in videos past looks something like this. This is the natural log of x. And this key point was 1, 0, meaning the natural log of 1 equaled 0. But now this is just further verifying that over here at 2.71828, so about right here, this would be 1. Okay, so the natural log of e, let me highlight it as I go. The natural log of e would give me a y value of 1. That's what's going on there. Very important, very important. I know we're e-learning, but I need to stress some stuff that will be very, very important later. Write 3 different expressions using each rule once that are all equivalent to log base 10, which is understood, of 36. Okay? So if I'm adding, you could say two numbers that multiply to get 36 could be like 9 and 4. Again, because our rules that we just learned is our 9 times 4 would be what we have combined in here. Because these were multiplication or addition, together they would combine into one log with the arguments multiplying each other. Okay? Again, I can only do this if the bases are all the same. Okay, so the bases are the same here. So I can do this next rule of you're going to divide. And numbers that we could say are like 72 and 2. Okay, and it has to be in this order because 2 divided by 72 is not 36. And that's what we're trying to get. So we have log of 36, otherwise log of 72 over 2. Okay, and then over here for 36, you could have something like 6 and 2 because that rule that we just saw, not only can we move it to become the coefficient, but we could also move it backwards. Okay, so when you're rewriting equations or whatnot, you're going to do this quite frequently, that you would move it backwards inside of the argument so that it would equal the equivalent of 36. 36 is here, here, and here.